Algebra 1, Section 9.8, Part 2. If you haven't watched Part 1 yet, you should be doing Part 1 before you do Part 2, and you really should practice problems 5 through 16 on your homework, and then you should watch this video right here. And basically what we're going to do now is we're going to apply what you learned in Part 1. Part 1, you learned factoring by grouping with a 4-term polynomial, and now we're going to apply this to 3-term polynomials. Now we're going to do 3 examples. And what you should notice about all 3 examples is that the lead coefficient is not 1. Okay, so this isn't exactly like the problems you were asked to do in section 9.5, right? 9.5, all the lead coefficients were 1, and that made the trial and error component to that factoring a lot easier than it would be here. Ultimately, you're going to be given a choice. Okay, when we get to section 9.6, I'm basically going to say, you need to be one or the other. You need to adopt factoring by grouping, and that's the way you factor things, or you factor by trial and error. And there isn't a better, one's better than the other. There are pros and cons to both, and it comes down to personal preference. Okay, so let's look at each of these 3 examples. And basically, what you need to know about this is that as we look at the first example, when we write something that's in standard form, what we will often do, and you'll see this in chapter 10 as well, is we'll substitute a number in for what we call A here. We'll substitute a number for what we call B here. That'd be understood to be a 1 right here. And then C would be this number, -3. So A is 2, B is 1, C is -3. If it's a 4-term polynomial, then A is still the first one, B is the second one, C is the third one, and the constant ends up being D. If it's a 9-term polynomial, then the 9th letter in the alphabet, whatever that is, A, B, C, D, I can't remember, would be the constant, okay? And I say that because what we're going to do is we're going to multiply the lead coefficient and the constant, what a lot of people will call AC. AC. If A is 2 and C is -3, then the product of those would be -6. Now, when I do this, I don't even bother with the negative. It doesn't really matter to know what the negative, whether that product is positive or negative, the way I teach this. So to me, it's just 6. Okay, I'm looking for numbers that are going to multiply to give me 6. And not only am I looking for numbers that are going to multiply to give me 6, I'm also looking for, of those, the numbers that are going to be different by 1. Recall in section 9.5 that it's this symbol right here which determines whether we're looking for a sum or a difference. That's still true. Okay, so as I look at 6, you could have 1 times 6, you could have 2 times 3. And the question then becomes, which of these 2 gives you a difference of this number here, 1? So obviously it's going to be 2 and 3. Okay, we're going to use 2 and 3. And then what you do with this problem, here's the factoring component now, the factoring by grouping, is you're going to rewrite this with the middle term, positive x, broken up into 2 terms using the 2 and the 3. So this would be 2x squared minus 2x plus 3x minus 3. Using the 2 and the 3, I chose -2 and +3 because these 2 terms would then add up to positive x. If this were negative x here, then it'd be positive 2x and minus 3x. Okay, but we want these 2 to actually represent what is here, which is positive x. And once you do that, then it's going to look a lot like the first part of 9.8. You're going to break this up into 2, kind of a front and a back. You're going to look for a GCF. That would be 2x here. And when I take 2x out of x squared, I get x. And when I take 2x out of -2x, I get -1. And in the second one here, I see a GCF of 3, which would leave me with x minus 1. And since both those terms are the same, we designed it that way. It's got to go that way if it's factorable. Well, then 2x plus 3, x minus 1s, if you will. 2x plus 3 times x minus 1. Now, a natural question comes up here, which is, what if we had done it the other way? What if I had flipped those 2 middle terms? What if instead of writing 2x squared minus 2x plus 3x minus 3, what if we said 2x squared plus 3x minus 2x minus 3. Now, when I say flip, I mean completely flip, right? Positive 3x is still positive 3x here. Negative 2x is still negative 2x. You can't flip the numbers and leave the signs where they are, or flip the signs and leave the numbers where they are. the 3 has to be positive, the 2 has to be negative so that they add up to give you positive x. This is an equivalent polynomial, unsimplified, to what we were given. All right, and again, just real quick, I'll factor by dividing it in half, factoring out, in this case, just x, which would leave us with 2x plus 3, and here factoring out -1, leaving me with 2x plus 3. And what do I have? X minus 1 times 2x plus 3. These are equivalent. The answer that I got here the answer that I got right there is the same as the answer I got right there, except they're just reversed. The parentheses are reversed. Both of those are a correct answer. Okay. Another iteration, if you will, of this concept, AC, 4 times 35. That's going to be 140. If you need to use your calculator, don't be ashamed. We're looking for numbers that multiply to give you 140. So you could take your calculator and take 140 and divide it by 2, see if it's divisible by 3, 4, 5, etc. Okay? So it could be 1 times 140. It could be 2 times 70. 3 is not going to go in. 4 times 35. What are we looking for? We're looking for numbers that add up to 24. And notice on the last problem we said had a difference of. Now I said add up to. I'm looking for a sum. That's because of this symbol right here. We're talking about the middle two terms, and they either need to be both positive or both negative to multiply to give you a positive number here. So I'm looking for a sum. This symbol says sum, whereas above, this symbol said difference. 3 minus 2 gave me the 1. Now I'm looking for numbers that add up to 24. Let's keep going. What about 5? 5 into 140 is 28. We're not there yet. 6 does not go into 140. What about 7? 7 and 20? Nope. 8? Nope. 9? No. 10 and 14. There's the one we want. After all that somewhat trial and error, and I don't confuse the words trial and error. We're going to actually use the term trial and error for factoring in section 9.6. But just try this until I come up with the right one. Oh, 10 and 14 do add up to 24. So what I'm going to do then is rewrite this problem, 4x squared minus 10x minus 14x plus 35. Breaking up the middle term using these two numbers into two terms, just making it unsimplified, so that then I can factor by grouping. Take out a 2x. The GCF of 4x squared and negative 10x would be 2x, which is 2x minus 5. Here you'd get a negative 7, which again is 2x minus 5. Process that for a second. Make sure I did that right. You take negative 7 out of negative 14, you get 2. You take negative 7 out of positive 35, you get negative 5. Whenever you're in doubt, you could always multiply it back. Negative 7 times 2x, that's negative 14x. Negative 7 times negative 5, that's 35. Okay, so I'm right. And this is then 2x minus 7 times 2x minus 5. And again, even now, if you wanted to multiply it out to check what you had in the original, you could do that, but this is correct. Okay, now you really could stop right now and go ahead and do the homework. I thought I'd do one more that's kind of extreme. These numbers are high, and this would be probably harder than any problem that I would give you, but if you can understand this one, you're pretty good to go. Okay, again, AC, 24 times 25, that's actually 600. And I'll be looking for a difference, again, looking at this symbol difference of 25 as I start to list them out. 1 times 600, 2 times 300. Okay, if I keep going at this rate, this is going to take me a while, so let me jump ahead. I know that 60 is divisible by 12, so 600 would also be divisible by 12. And if you divide 60 by 12, you'll get 5. If you divide 600 by 12, then you'll get 50. That's getting closer. What about 13? 13 is not going to go into 600. 14, I don't think so. 15, though, will go into 600. And you divide 600 by 15, you'll get 40. Okay? If we made this whole list, it would be a super long list. So try to use a little bit of number sense. Use your calculator as you need to. These are the two numbers that we want, 15 and 40. And again, I realize this is somewhat extreme, but what's life without a little bit of a challenge? So we're going to rewrite that middle term using 15 and 40. That would be minus 15x plus 40x. Again, if you flip those around, that's not a problem. Minus 25. Factor by grouping. Grouping is when you cut them in half like this. Okay, I'm grouping the front half and the back half. Factoring by grouping. And here I can take out a 3, I guess. 3x, which will leave me with 8x minus 5. Whereas here you can take out a 5. And that would leave you with, as you divide 40 by 5, you'd get 8, so 8x. 25 by 5 is negative 5. Now look, I always do that, with an honest spirit, right? I don't look ahead and go, oh, it's 8x minus 5, that's got to go here. No, I do the division, and then I know I've done it right when I come out with the same thing in this parenthesis as I had in the first one. And I'll know that my answer is right when I write 3x plus 5 times 8x minus 5. That's completely factored. Okay, good luck on the rest of your homework. That would be 17 through 25. Bye.